Welcome to Easy Alim Learning Simplified. My name is Ruth, and today we are going to be learning on the topic organic chemistry, and we're going to be looking at alkenes. So for today, we are going to look at the nomenclature of alkenes. What are the members of alkenes, and how are they usually named? So after that, we are going also to look at a few practice questions in regards to alkenes. So previously we looked at alkenes and also its nomenclature and even how it's prepared in the lab. So make sure you check out those videos in the previous lesson to be able to understand everything to do with alkenes. So let's start on the nomenclature of alkenes. So alkenes are hydrocarbons with at least one carbon-carbon double bond, and they have a general formula of CN H2N. Remember for alkanes was CN H2N plus 2. So you can see the difference between the nomenclature of alkanes and alkenes. For alkenes, it's going to be CN H2N, where N can be two carbons and above. So in this case, you notice we do not start from carbon number 1, as you notice, because remember it needs to have at least one double bond between a carbon and a carbon. So we need two carbons to begin with. We can't start with one carbon. And then they usually form a homologous series, and the simplest member being ethene. It's not supposed to be ethene, it's ethene. So just like I have said before, we do not have carbon number 1, that is, we start from carbon number 2 because we need to have the double bond between two carbon atoms. So in organic chemistry, alkenes are saturated hydrocarbons because they contain at least one carbon-carbon double bond, as you can see from the image. So this is unsaturated, unlike for alkanes where we said they are saturated. So alkenes are unsaturated. The double bond is a functional group. The carbon atoms are linked by at least one double bond to each other and single bonds to hydrogen atoms. So it needs to have at least one double bond. That tells you that we can have more than one double bond, but we will come to that later on as we name the compounds. So when you are naming, they usually end with a suffix "in", which is contrary to alkanes where they were ending with a suffix "in". And then the prefix will be meth, s. So in this case, you won't have meth. There's no methane. You'll have eth, prop, but, pent, x, and so on and so forth. So when we write them, remember we said we start with carbon number 2. So it's going to be ethene, s, and then in. And then you have propene. And then you have butene. And then you have pentene. And then hexene, heptene for number 7, octene, nonene, and then we have decene. So you notice when you're asked like a question in regards to alkenes and you're asked to write the first member is ethene, it's not methane. So first member, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and so on and so forth. So when you're asked to mention maybe the fourth member, normally the fourth member would be butene in an alkane, but the fourth member in alkenes is going to be pentene. So those are how we usually represent alkenes. So that those are the members of alkenes. Remember, we do not continue beyond carbon number 10. So beyond there, you're going to learn more later on in organic chemistry. So let's look at the molecular formula now of alkenes. Molecular formula, we said it shows the type of atoms and how many they are. So if you start with ethene, remember the general formula for alkenes is CN H2N. So ethene is carbon number 2, so it's going to be C2H, 2 times 2 C form. And then we go to propene. So it is C3, then H, 3 times 2, 6. And then we go to butene, which is going to be C4. 4 times 2 is 8. And then we have pentene, which is C5, 5 times 2, H10. And then we have hexene, which is C6, which is going to be 6 times 2, which is 12. And then we have heptene, which is C8, C7, H14, that is 7 times 2. Then octene, which is C8, 8 times 2, which is 16. And then nonene, which is C9, 9 times 2 is 18, H18. And then we have decene, which is C10, 10 times 2 is 20. So that's the molecular formula. It shows the types of element present and how much. And then also it can be presented by structural arrangement where we open it up. So for example, in our ethene, we had we had 2 carbons with a double bond, remember? So we need to count. This is where counting the number of bonds of carbon is important. So you see these carbons already have 2 bonds. So this carbon requires 2 more bonds bonded to the hydrogen. And also this one requires 2 more. And then we go to propene. So these are 3 carbons. Then you introduce the double bond and then we start counting. This carbon has 1, 2. It requires 2 more. And then this center one has 3 already. You can see 1, 2, 3. So we put a hydrogen here. And then this other outer carbon has only 1 bond. So it requires 3 more to completely be full. It's important that you count. And then we have butene. So this is going to be 4 carbons. And then one of the carbons will have a double bond. Once more, you can see this carbon has 2 double bonds. So it requires 2 more double bonds. This inner carbon has 1, 2, 3 bonds, so it only requires 1 bond to be full. This carbon has 2 bonds on the outer part, so it requires 2. And finally, the last one has only 1 bond. It's bonded to 1 carbon, so it requires 3 more to be full. So we go to pentene. These are 5 carbons, so we draw the 5 carbons. So those are the 5 carbons. We put a double bond here. So this carbon has already 2 bonds bonded to it, so it requires 2 more. And then this inner one already has 3 bonds bonded to it, so it requires 1 more. And then this carbon has 2 bonds, requires 2 more. This carbon has 2 as well, so it requires 2 more. This has 1, so it requires 3. Always count. And finally, we can do one more, hexene with 6 carbons. So you draw the 6 carbons and then you introduce the double bond. So this carbon already has 2 bonds, so it requires 2 more. This one has 3 bonds, so it requires 1. This one has 2, so it requires 2 to be full. This one has 2, so it requires 2. This one has 2, so it requires also 2. This one has 1, so it requires 3. So it looks like that. So we remember we said for structural formula can also be condensed. So we can show how they're arranged, but in a condensed manner. So in case we condensed the ethene, we would write it as CH2, CH2. For propene would be CH2, CH, CH3. That's how it's look like. For butene, it would be CH2, then CH, then CH2, then CH3. For pentene would be CH2, CH, then CH2, CH2, and CH3. For hexene would be CH2, CH, CH2, 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 and CH3. We said you can also write this one by condensing it further, so it will be CH2, CH, and any CH2 is placed in a bracket, and there are two of them. So instead of writing these two, we just put it in a bracket and then CH3. So these are the structural formulas. You can open them. This is the open formula. This one is condensed. So either way, you notice you're going to see either one of them, especially when you're interacting with alkenes. We also have skeletal notations where the carbons are not shown and the hydrogens, but we use zigzag lines to show carbons are present. So every end of a zigzag line shows a carbon atom. So let's present the elements, the members of this group. So first we have ethene, and for ethene, if you want to show zigzag, we need two lines. So you show the first line and then a smaller line to show the board. So this tells you there's a carbon at this end and there's a carbon. Remember, we do not show the hydrogens. Rarely will you see ethene being notated in skeletal notation because of just the two carbon atoms. But when you come to propene, that has three, so you draw the first one and the second one. You can see there is a carbon here, and carbon here. So if you want to place the double bond in the first carbon, you place a smaller line below it. So we go to butene. Butene has four carbons, so we are going to draw four lines, one line, two lines, three lines. Actually, it's three lines. So you put, this is the first carbon, second, third, fourth. The dots are usually never placed. I'm just placing them so that I can show you where the carbons are, and then you put a smaller line to show the double bond. And then we have, we can do pentene as well. So we have this line, this line, this line, and this line. So the dot will, this is one of the carbon, the second carbon, the third carbon, the fourth carbon, and the fifth. So we draw a smaller line in the first carbon here to show the double bond. So for hexene, the same thing. So we have a line. So there's one carbon here, 2, 3, and then 4, 5, and then 6 here. So we draw a smaller line to represent the double bond. And then we look at heptene. So heptene is 7. So 1, 2, 3, 4, 5, 6, 7. And then we put a line here to show the double bond. And then octene is going to be 1, 2, 3, 4, 5, 6, 7, 8. And then we put a small line to show the double bond. And then nonene is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we put a line here. And finally, decene, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then you put a line here. So that's how you represent the alkenes. You can show them by a molecular formula, structural formula, which can be open or condensed, and then we have the skeletal formula. So when we go to naming, you're going to notice you're going to be using ether, especially when we name our compounds. So you should be able to name them comfortably when we get there. So that's it for today. So in the next lesson, we are going to look at the rules for naming alkenes. See you in the next session.